This video is about terrestrial planets. Terrestrial planets are planets that are made mostly of rock and metal. And because of this, they tend to have high densities, being denser than the average gas giant. And generally, having more metal makes the planet denser. They also tend to have metal cores, and this is because during the early years of a terrestrial planet, right after its formation, the surface tends to be partially or completely molten. And this is because of the amount of matter that's constantly colliding with the planet during this early stage in its life, from regular asteroids to even other planets. And this state of being molten allows for the heavier metals to sink into the core. They also tend to be much smaller than gas giants and ice giants. Our own solar system has four terrestrial planets. They are all located in the inner solar system, but this does not necessarily need to be the case with all terrestrial planets. Mercury is the smallest and has no relevant atmosphere. Venus is slightly smaller than Earth, about 70% of Earth's mass, but is actually the hottest planet, and it's hotter than Mercury despite being farther away from it because of the planet's extremely thick atmosphere, which is made almost entirely of carbon dioxide, causing an extreme greenhouse effect that constantly heats the planet. Earth, the third planet, is our home and the only planet that we know for sure to have life. Mars is the fourth and last planet and is much smaller and has a much smaller atmosphere than Earth, of only about 1% the thickness of Earth's atmosphere, and is the coldest terrestrial planet in our solar system. Now, extrasolar planets or exoplanets can also be rocky and made of metal. Most of the terrestrial exoplanets we found so far are called super Earths. These are planets that are larger than Earth but smaller than ice giants like Uranus and Neptune. They can often be radically different compared to what we know, but also be oddly similar at the same time. And we found a decent number of these that orbit in zones known as the Goldilocks zone, where theoretically, if the planet had an atmosphere, the planet would be orbiting in the orbital range of its star where liquid water would be able to exist on the surface. Terrestrial planets are extremely diverse. For example, we've already seen in our solar system, Mars is cold and has a thin atmosphere, Venus is boiling and has a crushing atmosphere. Those two planets are basically polar opposites. As for exoplanets, it's very likely that super Earth planets are going to have much thicker atmospheres than Earth, but these atmospheres probably won't be as so thick as to make them hostile to life, like Venus's atmosphere. It's also possible that uh, many super Earth planets could be what are known as water worlds. And these are worlds that receive so much water during their early formation years that their surface is completely covered in a single vast ocean that is much deeper than even the deepest parts of oceans on Earth. And these planets would present their own unique challenges to any forms of life that would evolve on them, because obviously there is nothing for life to cling on to. And sometimes it has been doubted if complex life can even form on these planets at all. And then, of course, on the opposite end, there are smaller planets that may have very small atmospheres or no atmospheres at all, especially if they orbit a star that's less stable than our sun, because our sun is actually very stable as far as stars go. this is the end. I hope you liked this video and learned something. Please like this video and subscribe to my channel.